Well, I'm glad you're back. And now we'll be looking at scientific notation. We have several objectives to cover today. We'd like to recognize numbers in scientific notation, convert numbers from standard form to scientific notation, convert numbers from scientific notation back to standard form, be able to multiply and divide using scientific notation, and use your calculator for scientific notation. Let's first of all talk about what scientific notation is. Scientific notation is just a shorthand way for writing very large or very small numbers. It's primarily used in the sciences. For a number to be written correctly in scientific notation, it will be written in the form c times 10 to the nth power, where c is greater than or equal to 1 and less than 10, and n is an integer. An example of that would be 3.62 times 10 to the 8th power. Notice that 3.62 is indeed between 1 and 10, and 8 is an integer. Another example would be 8.93 times 10 to the negative 5th power. Please remember that negative 5 is an integer, so this is indeed written in correct scientific notation. Let's look now at some examples of numbers written in standard form and scientific notation. The first one we'll look at is the distance to the sun. In standard form, you see 93 million miles with the 6 zeros, which is what you're used to seeing. But to convert that number to scientific notation, let's look at what we would need to do. Notice that in standard form, there's a decimal assumed to be at the end of the number unless you see one somewhere else. So our decimal is at the end of this. We want to move that decimal until we have one digit to the left of it that is non-zero. So if we begin that moving process, we start here, we would move 3, 6, 7 places to our decimal right there. So you'll notice what we have here is 9.3 times, and since we moved 7 places to the left, we have a positive 7. Our next example is the time required for light to travel 1 mile. Notice, written in standard form, we have a very small number here. We want to write it in scientific notation. We'll need to move our decimal once again until we have one digit to its left that is non-zero. As we start that move, you'll see we move 3, 6 places. We end up with 5.38. Because we're moving our decimal to the right, notice that we have an exponent of negative 6. And our last example here is the estimated world population in 2050. Notice our decimal is once again understood to be at the end of this number, and so as we begin to move, we'll count. We'll move 3, 6, 9 places, so we end up with 9.0, and because we moved 9 places to the left, we have an exponent of 9. Let's practice now and write some numbers in scientific notation. What I'd like for you to do is pause this video, do these 4 problems, and then come back to check your answers. I hope you're back now checking answers, and so let's talk our way through these. Once again, our decimal is understood to be at the end, so as we begin that move, we'll go 3, 6, 9, 12, but we're not quite there yet, 13, 14. So our decimal will end up here. We'll have 1.25 times 10 to the 14th power. To convert our next number into scientific notation, once again we'll begin our move. 3, 6, 9, 10, 11 this time. And notice that since we're moving to the right, our exponent will be negative, so we end up with 3.478 times 10 to the negative 11th. In this next one, our decimal is once again at the end, and so we'll begin our move. We're moving to the left, so tell me the sign of that exponent when we get finished. We're looking for a positive number there. So here we go with our move. Let's go 3, 6, 9, 1 digit to the left right there will put us with 10, so we'll end up with 4.3 times 10 to the 10th power. And for our last one, we're once again expecting that exponent to be negative, and so as we begin to count, we'll see 3, 6, 7, 8, and we'll end up with 7.54 times 10 to the negative 8th power. Now what I'd like for us to do is write each of the following numbers in standard form. They're given to you in scientific notation. Once again, I would ask you to stop the video, do these 3 problems, then come back to check your answers. Let's continue now to check. Because the exponent in this one is a negative 5, we're going to move our decimal place to the left. Our first move is right there, so that counts as 1, and then we'll need to add 4 zeros out in front. That will give us 0.0000364 written in standard form. For our next one, we need to notice that the exponent is a positive 7, which means we'll be moving that decimal to the right 7 places. Our first position is right here, followed by 6 zeros. So we get the 46 million. And for our last one, our decimal is here. We'll be moving it to the left because the 8 is negative. Our first position is right there, preceded by 7 more zeros. Next, we'd like to multiply using scientific notation. We now have 3 times 10 to the 4th power times 2 times 10 to the 5th power. To multiply these together, we need to remember that the commutative law of multiplication allows us to rewrite the order in which we multiply these items. So what we'd like to do is place together the 3 and the 2, and then the 10 to the 4th and the 10 to the 5th. So when we do that, what we get is 6 times 10 to the 9th power. Let me remind you, this 9 came from 10 to the 4th and 10 to the 5th. When we have like bases, we add exponents, and so that's where our 9 came from. The next thing I'd like to ask you is this number written in correct scientific notation? If it is, there is 1 digit to the left of the decimal, and the exponent is an integer. So let's look at that. Our understood decimal is right here. There is 1 number to the left of it, a 6, that is non-zero, and if you'll notice, the 9 is indeed an integer. So what we have here is in correct scientific notation. Let's continue to another example. This time we want to multiply 6 times 10 to the negative 12th power times 6 times 10 to the 5th power. Once again, let's regroup and let's put our 6's together and our 10 to the negative 12th times 10 to the 5th together. When we do that, we get 36 times, once again I want to remind you that negative 12 plus 5 is indeed a negative 7, so we end up with 36 times 10 to the negative 7th power. Is this number written in correct scientific notation? If it is, there's 1 digit to the left of the decimal. So let's look. Where's our decimal in this first part? It's at the end. This time you'll see that there are 2 digits to the left, so we must move the decimal. So let's make our move here. Since we're moving this to the left, as this number gets smaller, our exponent should get larger. So the 36 becomes 3.6, and our negative 7 will become, instead of a negative 7, a negative 6. Let me remind you one more time. As this number over here gets smaller, which it did, the exponent will get larger. Because these numbers are negative, it looks a little funny, but a negative 6 is indeed larger than a negative 7. Now what we'd like to do is do scientific notation with your calculator. So let's start that process. We first need to set your calculator in scientific notation mode. Your steps for doing that are Mode, use your right arrow to move to SCI, hit Enter, and that will actually change your calculator to scientific mode, and remember you always second, mode, or quit to get out of that process. Once we're in scientific notation mode, any number we enter, the calculator will convert to scientific notation. So let's enter 376,000,000,000,000. When you do that on your calculator and you hit enter, your calculator will come back with 3.76 E11th. You need to understand that when you see an E and followed by a number, that your calculator has changed whatever number it's working with into scientific notation for you. This number is actually 3.76 times 10 to the 11th power. This is the way you would need to write that number to write it correctly. The calculator simply writes it with an E. I need to remind you that once you're in scientific notation mode, everything you do on your calculator will stay in scientific notation mode until you take your calculator out of that mode. So I want to go through the steps for taking your calculator out of scientific mode. The steps are Mode. This time move your arrow to the left to get back to normal, hit enter, and then once again second quit. Let's enter numbers now on our calculator in scientific mode. Let's say we want to enter 4.2 times 10 to the negative 3rd power, and we want to enter this exactly as you see it in scientific notation. Our steps for doing that are 4.2. We do not write the times and we do not write the 10. Remember how your calculator simply used the exponent? Well, we need to tell it now that we're going to enter the exponent. And we do that by entering second, comma, which is an EE, and then the exponent. In this case, a -3. When you enter that on your calculator, it knows that what you have entered is actually 0.0042. I want to point out to you one more time that on the calculator it displays a single E while you actually entered a double E. Let's do another problem now. Let's multiply using your calculator. We want to multiply that 4.2 times 10 to the -3rd power times 6.4 times 10 to the 14th power. We want to do this without leaving scientific notation. We don't want to go into standard form, multiply, and get an answer like that. So we're actually going to stay in scientific notation even on our calculator. Our keystrokes for this are 4.2, E, -3. Notice that we put the first number in parentheses and then we'll put our second number in parentheses, 6.4, E, 14. When you hit enter, your calculator will come back with 2.688 E12. I need you to recognize that what you actually have here is 2.688 times 10 to the 12th power. This time we'd like to do an example where we will divide two numbers using your calculator. This time we'll divide 4.2 times 10 to the -3rd power by 6.37 times 10 to the 12th power. Please remember that anytime you have a fraction, you need to write the numerator and denominator in parentheses. So once again, we'll open parentheses 4.2 e to the -3rd divided by 6.37 e to the 12th. When you hit enter this time, you get a really long number there, e to the -16th power. I'm going to round it to 6.59 times 10 to the -16th power. Well, that's all I have for you today. I'll talk to you again soon. Bye-bye.